Hi, I'm Mr. V, and today I'm talking about Illustrative Mathematics, Unit 3. Only these are lessons that I've created because we have a compression of time. We only have a limited amount of time to discuss this entire unit before the end of the trimester. So in this first unit, we're going to be looking at proportion and ratio. And by the end of the period, you should be able to say, I could determine a scale factor between two figures. I can dilate a figure given a scale factor in its center, and I can solve proportions using scaling and scale factors or using the cross product property. Now, all of the problems and all of the pages in this activity are ones that you should do and try to do. And look at this video afterward to see if you need help. I'm going to go through each of the pages and each of the problems and show you some different strategies that you might use in solving the problems, but you should try to do them yourselves first. Okay. That said, first thing we'll look at is the warm-up, this flagpole. I'm 6 feet tall. At a certain time of the day, I cast a 2-foot shadow. At that same time, the flagpole casts a 10-foot shadow. Drawn in the drawing on red, answer the questions at the bottom of the page. And the questions are, how tall is the flagpole? Draw auxiliary lines for this situation. And what is the scale factor of my height to that of the flagpole's height? Said another way, how many of me will it take to make the height of the flagpole? And here I have the flagpole. I've drawn the auxiliary lines. Notice these lines are parallel. They have a slope of, if I go a rise of 3, I'll do a run of -1, rise of 3, -1. So if I do the same thing all the way up here, I'm going to get up to what looks like it's going to be is 30. Now, to show you, move this picture of me over somewhere down here. Yeah. To show you how we could set this proportion up, I'm going to redraw the picture. Here I am. I'm 6 feet tall. My shadow is 2 feet in length. The flagpole is 10 feet in length, and we don't know how tall it is. So we put an X here. These two triangles are similar. Notice the sun, the ray of the sun is going to be the same for both the shadow of the flagpole as my shadow. And we're both at 90 degrees from the ground. So we have two angles that are congruent. What can you say about that third angle, the one right here and right here? Well, those would also have to be congruent. Tomorrow we'll be looking at one of the conditions for similarity, which is angle, angle, triangle, similarity, which is a tilde theorem. We're looking at this theorem tomorrow. But for today, I'm looking for X, and I could say if I'm 6 feet and my shadow is 2 feet, the flagpole, we don't know how tall it is X feet, and its shadow is 10 feet. One way to solve this is to use the cross product property. I can multiply the extremes and the product of the means and the extremes. When you multiply them together, this would give you the same, the way to solve the proportion. So I have 2x is equal to 60, or x is equal to 30. That's one way of solving this. A different way you'll notice is I might have looked at this and said, well, 2 goes to 10. I could just multiply this times 5. When I multiply going this way times 5, I get 6 times 5 is equal to x, which is equal to 30. It's the same answer as what I had down here. So I'm scaling it going up like this instead of cross multiplying. Notice I can multiply 6 over 2 times 1, and it's not going to change the value. It'll just change the way it looks. My 1 looks like 5 over 5. When I do that, I get 30 over 10. 30. Next page. A ratio. The definition of a ratio is a comparison of two numbers. So you could write the comparison of A to B, or you could write A colon B. But most practical for mathematics purposes is this third way of writing it as a fraction. And we would say A is to B is the way we would write. We'd say that. Instead of A over B, just say A is to B. A proportion, by definition, is an equation of two ratios. If you do not have an equal sign, you do not have a proportion. And here we have two triangles. These triangles are similar, which we'll learn tomorrow by the angle-angle similarity theorem. How many different ways can you write this proportion? Please try it out and then watch my video as I explain to you how I would write it. I'm going to make this smaller, this video. You don't need to see my face doing this, and can't see it very well anyway because it's kind of dark over here. So I'll put this over small. Now, I'm going to compare the small triangle to the large. This side matches with this one. This side matches with this one. So these are not equal. A is not equal to C. But the proportion A is to C as B is to D. The proportions are equal. And if I flip this, I get C is to A as D is to B. This works as well. This is the same thing, only it's going in the opposite direction. It's going from the large triangle is to the small as the large is to the small. We could also write the small side is to the longer side as the smaller side is to the longer side. So I could write C is to D as A is to B. And if I reverse that and go in the opposite direction, the longer side is to the long side to the short side, long side to the short side, then I get D is to C, this thing flipped as B is to A. What do these all have in common? These are all correct for one, but if you do the cross product property, I'll get A times D is equal to B times C. A times D, B times C. A, D, B, C. A to D, B, and C. These are 5 different ways that are valid for writing a proportion. And what you don't want to do is to mix apples and oranges. And I'm going to show you 2 ways that you don't want to do. One way is to go A is to B, short leg is to long leg, as D is to C, the long leg is to the short leg. That doesn't work. I'm going around in a circle here. A is to D. Notice I'm going in the blue direction. The blue direction has gone the same direction. The other one is I could do it this other way. So you don't want to go A is to C as D is to B. Don't do that. Those are wrong. So be careful with what you're doing and make good choices, and you'll do fine. In our next segment, next portion of this, we have practice with proportions. Which of these must be true? Please try this on your own and then look at my solution here. I'm going to go this way. Using the cross product property, which is the way to solve any proportion. There are easier ways and other ways, but we're going to look at the cross product property. We multiply the means, the y times 5 times is equal to the product of the extremes. So I get 8x is equal to 5y. And that's the equivalent of this. Any of these other expressions that look like that, they must be true. So the first one has to be true because it's the same thing. The second one is not the same, is it? So this does not work. The third one, well, let's multiply it out. 8 times x is equal to 5 times y. This works. This is the same. The next one, 8x is equal to 5y. This guy's flipping this one. This one is going sideways. 8, let's see, x is to 5 as y is to 8. This works as well. What doesn't work when I do the cross product property, 5x is not equal to 8y because we know it has to work up here. So this does not work. Then we come to one that's a little bit different. I'll give this one with an x and a y. Now notice this horizontal line, this divided by sign, is a grouping symbol. Some people don't realize that. I've written the grouping symbols with the parentheses here, but if you don't have parentheses, remember to write them so that when you do the cross product property, you don't get 13y is equal to 8 times x plus y. This would be incorrect. You have to put the parentheses. And we'll distribute the 8 over the addition to get 8x plus 8y is equal to 13y. And when we subtract 8y from both sides of the equation, we get 8x is equal to 5y. This is a correct way of writing it. This is true. It's the same as our original. This works. For this next one, we could work it out with the cross multiplying. I'm going to simplify the fraction as 5 over 8. See, there's a 2 in common. And now when I do the cross product property, I get 8x is equal to 5y. This works as well. Here, I get 4x is equal to 10y when I cross product. That's not true. And if I simplified it, I would still get 2x is equal to 5y. So the 5y part is good, but the 2x doesn't work. Maybe you're multiplying the 1 by 2 and dividing the other one by 2. This is not good. This does not work. And this last one, the same way, you might have a math error if you don't look out. So let's do our math and do it step by step. It's just algebra. 3x is equal to 5 times the parentheses, x minus y. Distribute the 5y, and we get 3x is equal to 5x minus 5y. I will subtract 3x from both sides. 0 is equal to 2x minus 5y, and add 5y to both sides. 5y is equal to 2x. If you had added 3x here to both sides and said that's equal to 0, that would be incorrect. That would be 6x. But that would give you the 8x, and that's what we were looking for, is 8x is equal to 5y. This is incorrect. This does not work. Going on. When you solve proportions, we can use the cross product property. It says the product of the means, these two, is equal to the product of the extremes. Why does this work? If I multiplied both sides here by b, this would cancel, and I get c times b. Multiply both sides by d, the d divided by d is equal to 1, and you get a times d is equal to c times b. So let's do some practice with them. I have some practice problems set up for you over here. I could apply the cross product property and get 3x is equal to 36, divide both sides by 3x is equal to 12. I could also simplify this to begin with. This is 3 over 1. Now when I do the cross product property, I get x is equal to 12 directly. Here you could multiply this out and say 11x is equal to 6 times 22. But I also might want you to notice that if I scale this up by a scalar of 2 times 2, I could scale this piece up by 2. So if x is equal to 6 times 2, that's equal to 12 here. Doing it out, you have 132 is equal to 11x, so x is equal to, divide both sides by 11, x is equal to 12. Just a little bit more work, maybe. When you go to take the SAT or ACT test to get into college, it's timed. You want to be able to do this as quickly as you can. Here I'll do the cross product property. 7x is equal to 15. If I were to simplify this, I get x is equal to 15 over 7. This is an improper fraction, and I like improper fractions. I don't like mixed numbers, and I really don't care for decimals. Not when we're talking about proportion, which is a ratio. So I like it like this. This is good. As an engineer for 20 years, I know that using proportions, using ratios, is a lot easier to use when I'm multiplying a long string of numbers than by just sticking in decimals and sticking it in a calculator. Here I have 4x is equal to 3 times x plus 2. Uh-oh, what's wrong with that? Didn't group it. Make sure that you group this. So now I have 4x is equal to 3x plus 6x is equal to 6. This is a geometric mean. When two of the means are identical, this is not an arithmetic mean, which is an average. This is what's called a geometric mean, and we'll study that later. Here we have x squared is equal to 64. Some of you may have said the answer is 8, and 8 would be incorrect. When you take the square root of a number, you're going to have to take a plus or minus is your answer. So if I were to graph x squared looks like this. It's a parabola. It goes like this. And if I were to graph the 64 on the other side of the equation, notice it crosses here in two different places. So my x value is equal to plus or minus the square root of 64, which is plus or minus 8, and that's the way we would write it. So that would be the correct answer. This may be new to some of you, this idea of taking the square root and plus or minus. In geometry, we often ignore the negative root, and so we get a positive root, and we forget about the negative root. But in Algebra 2, you will need this. Here we have 3x is equal to 5 times parentheses, x plus 1. Notice I use the parentheses here. So we have 5x plus 5 is equal to 3x. I'll subtract 3x from both sides in order to isolate, get the x's all on one side, and I get 0 is equal to 2x plus 5. How long does it take to write it out? Not very long. You can do this yourself. So negative 5 minus 5, I get negative 5 is equal to 2x. Divide both sides by 2, and I get x is equal to, this is a giant 1, x is equal to negative 5 over 2. I like it like left like this. Is this what you got when you did it? Now, you have two ways and strategies of solving proportions. One is to use the cross product property, which always works. Another one is to use a scale factor. So if you scale the bottom, you scale the top. You could also do that same scaling up and down. So for instance, if I had two numbers, let's say 2 is to 8 as 7 is to x. If I scale this going down times 4, I could scale this one times 4 as well. And instead of doing the cross product property, I end up with 4 times 7, x is equal to 28. So just a couple of ways of applying this scalar business. This is some more practice with proportion. I think we just did these. Make sure that you use parentheses when you have a grouping symbol, when you have a binomial, such as x plus 2. This is a different practice. It's a different kind of practice. We're supposed to tell whether the two ratios are proportional. Are they equivalent ratios? And one way to do this is to do the cross product property, and you could do that for every one of them. However, there might be some techniques that you could use that would preclude you from using the cross product. So if I multiply both of these out, I would get 105 for 5 times 21, and that is equal to 105. And yes, that's one way to tell me that they're the same. I could also say, if I scale this up times 7, and this one up times 7, my 5 times 7 is 35, and 3 times 7 is 21. This works. Here, if I scale 9 up times 3, I would get 27. Do I scale 4 up times 3 and get 18 times 3? No, I don't. These are not proportional. And I can just look at it and see. What about this one? Well, this one is a little bit less difficult, less easy to see. Notice I have a geometric mean here. These are the same. 24 times 24. I'm going to write it out. And this equal to 9 times 64. If you're asked to do it without a calculator, which won't be asked by me to do that, but you might on a test to do that on a SAT or something. This is 3 times 3. This is 8 times 4. Well, 8 times 8. 8 times 8 is 64. And 3 times 4 is 24. 3 times 8 is 24. 3 times 8 is 24. These are the same. Here, you might not recognize it. These two numbers have a 3 in common. This is 3 times 5, and this is 3 times 7. That's like 1 times 5 times 7. These have a denominator in common. It's 11. 11 times 5 and 11 times 7. This is like 1. 5 times 7, 5 over 7 is equal to 5 over 7. So those are equivalent. You can try this, scaling this up with the scale factor. We may do it again tomorrow. Here are some notes on scale factors. Please pay attention to this. So here if I have a scale factor, we'll call it K. I take this original figure and I want to scale it, make it larger, make it double. So I'm going to go this distance, and I'll go this distance double to get to this point. Now I want to take this next distance and I want to take it double to get to this point. And same with this other one to get to this point. So when I get it larger, it's going to be scaled up. Notice my scale factor here would be greater than 1. If the scale factor is equal to 1, I'm going to have the original drawing that I have. This would be congruent figures. By the way, if factor is equal to 0, then that means I get my point of dilation. There is no scaling by 0. You may not scale by 0 because all that gives you is the point of dilation. If I'm going to scale between 0 and 1, so it cannot be equal to 0, but it can be greater than 0 and less than 1, because if it's equal to 1, it's equal to congruence. And that would give me a smaller factor. I want to just point out here, if I have two similar figures, they say they have an angle here and an angle here that's the same, and they're different, and this larger one is 5, and this is where I started from. I'm going to this small one, say it's a 2. My scale factor would be the larger number goes in the denominator, and this, when I'm going to, is in the numerator. So I don't multiply this by 5/2. That would get me larger. I would multiply 2/5 to get to the smaller version. And then we have some practices. I'll just walk you through this first one. We're going from the blue to the red. Originally we're at 3. What do you multiply 3 by to get to 2? You multiply it by 2 over 3, or 2/3. And you can check your answer on each of these where I actually write it out for you. So my scale factor is 2/3. There's some practices here to do. I'll give you the answers. There's also this question on the error analysis. And I give you the answer here too, but try to figure it out yourself. What's wrong with this? This person made a grave error, made a very big mistake. X can't be 56. The perimeter of this is not going to be larger than the perimeter of this one. That's not correct. And then there's 2 of these. Tomorrow or next time we meet, we'll be studying angle similarity, where we take the one figure and reconfigure it, redraw it to where it looks like this one. And that may make it easier for you to be able to solve for these variables. There's 2 of these before the end of the lesson. Good luck and success.